Hi, I'm going to go through the what should be the hard questions in the exercises, so the last questions of the exercises and the challenge questions if there are any there. So we're going to go through these questions today, 6, 7, 8, and then the challenge. It's chapter 13.4 about definite integrals, and it's exercise 13D in the year 1 pure book. So, first question, let's have a go. These questions aren't too tough. It's just again a skill of changing this into something we can integrate. So I know that is going to be 2x to the power of negative a half. So I am integrating between 12 and 4 2x to the power of a negative half with respect to x. So when I differentiate this, I'm going to get 4x to the power of a half because I've added 1 to the power and then divided by it. So I've added 1 to the power here to get half, then I've done 2 divided by half, which gets me 4. And I'm going to go between 12 and 4. So what I need to do is substitute 12 in here and do the subtraction of substituting in 4. I'm not going to go into great depths of why we do this, because if we're at this stage we should have already had that teaching done for us. So this is 4 root 12 subtract 8. We know root 12 can be written as 2 root 3, so that's going to be 8 root 3 subtract 8, and if we're being really specific and put it in the exact form they want, I'll switch it round and I'll put it like this with my integer first and my integer with a third next to it second. So that's the answer to the first one. Question 6. Question 7. A little bit more thinking to do, same concept, so let's change this, for some reason I like, into the power of this minus half business. But we're going to integrate between k and 1. And we're actually told that this is equal to 3. So you can see, you can probably predict how this question is going to go. We're going to get some stuff involving k and then we're going to solve an equation. Whether it just be a linear or a quadratic or something, we'll find out. I'm going to ignore this section for now, and I'm just going to keep doing my workings down the line of just my integral. So when I integrate this, I'm going to add 1 to the power. I'm going to divide by it. So I'm going to get 2x to the power of a half, and I'm going to do this between k and 1. So substitute k in. I'm going to turn that power of a half back into a square root, just because it looks nicer at this stage, and that's going to be subtract 2. Remember your plus c's in there. I probably forgot that in the last question, and you were probably shouting at me, I hope. So always put your plus c in there, even though they always cancel out. It's a bit pointless, but it is mathematically correct that we've got the constant of integration there. So carrying on, so we've got 2 square root k subtract 2, and I'm going to bring back in my equals 3. So adding to the side, adding 2 to both sides I should say, we get this. I'm going to divide by 2. Probably better to say 5 over 2 at this stage, and then I'm going to square it. So got square root, so squaring it, we're going to get k equals to 5 over 2 squared, which is 25 over 4, 6.25 if you want to put it like that. 25 over 4, I like it, or you can say 6 1/4, you can say all sorts. Anyway, that's what k is. So, question 8. absolutely hated this question, not for the fact that it was hard, for the fact that it feels like when I did it, I didn't use this top half at all. And they shouldn't. You need to get used to being given false, pointless information, because in real life you get so much information and you've got to figure out what I'm using. But generally in questions, if we get given something, it's going to be useful. In this case, it wasn't at all. So, finding the value of s. In finding the value of s is just if we do this sum. Just do this definite integral here. So between 10 and 0 of 20 plus 5t. So let's integrate this. We're going to have 20t plus 5 over 2 t squared between 10 and 0. So sub in 10, that's going to be 5 over 2 times 100, which is going to give me 250, plus c. Subtract, well, that would all be 0, so we'll just be subtracting c. These cancel out, and we just get 450. Like, for question 8, doesn't seem right how it was so easy, but it was, and that is the answer they were looking for. I don't know why that was a question there, but hey, it might have confused you from how easy it seemed to be. And then our challenge question. This is stuff that's more like it. So, again, we're told what it equals, and we need to find the value of k. But we've got k on top and bottom this time, so it's even harder. First, I'm going to split this. So 3 over 8 x plus a quarter dx equals 7. Again, I'm going to ignore this for now, and I'm just going to work down in my steps. When I do this little arrow, it means continues on from. I like doing that just to, it's nice working out, it's nice laying out of work. So, let's go and integrate this. We're going to, I don't want the power divide by it, so we're dividing by 2. So, 3 over 16 x squared plus a quarter x. I'm doing this between 3k and k. So substituting in our 3k, we're going to get 3 over 16, 3k squared is going to be 9k squared plus a quarter, 3k plus c. Subtract, substituting in k now, so 3 over 16 k squared plus a quarter k plus c. Again, our plus c's cancel. I know it seems boring and pointless, but we got to do it. Move my cursor right. So let's go ahead and expand some of these. So 27 over 16 k squared plus 3 over 4k, subtract 3 over 16k squared. That will be a subtract because we're subtracting a positive. That always seems to catch people out in these integration questions. They'd only carry the negative through to the first term and not through to all of them. I mean, I made that mistake for a moment until I spotted myself, so it's easy to do. And that is going to equal to 24 over 16k squared plus a half k. It would have been 2 over 4, but I've made it a half. I'm bringing back in that equals 7. So we've just got this now, which seems like something we can work with. So let's times it by, well, let's simplify this actually. So I'm going to get my ruler and I can simplify 24 over 16 to 3 over 2. So let's times by 2. 3k squared plus k. I'm going to also take the 7 to the other side at the same time. It would have been plus 14 on the right hand side of the equals, and I've just taken it away. Factorising this, we're going to get 3k plus 7, k minus 2 equals to 0. So So therefore, that triple dot means therefore, k is going to equal to minus 7 over 3, or k equals 2. Back into the question, it says k is greater than 0. So we can say this solution is a load of bogus, and this solution is good. Write a little sentence. Say, as k is greater than 2, k is greater than 0, k equals 2. And that's the challenge question done from there.